In this video, we're gonna work on some examples of dot products. So let's start. The first example is to find the dot product between these two vectors. 4, 0, 5, dot product with the vector -1, 0, 0. Okay. We know that the dot product, I need to multiply each of the components by the corresponding component. So it would be 4 times -1 plus 0 times 0 plus 5 times 0. So it would be -4. Example 2. Find the dot product of the vectors 2i minus 3j plus 4k, dot product with 3i plus 9j. So I'm gonna multiply 2 by 3, so it would be 2 times 3, and then I get I dot product with I. So we know that a product of a vector times another but by itself would be the length of the vector square. So the length of I is just 1, so it would be 1 square, so 1. And then I get -3 times 9, so plus -3 times 9, and then I have j dot product with j, okay? And then, so this is 1 again, and then plus 4k times 0, so plus 4 times 0, and then k dot k. So I can write this 2 times 3 plus -3 times 9 plus 4 times 0, so together I get 6 minus 27 plus 0, -21. Okay, good. Another example, example 3. Just assume that this is x-axis, I have y-axis, and then I have z-axis. Let me make them black. And then I have, I have a point in here, the point R 0, 0, 1. Then I have another point P 1, 0, 0, and I have another point in here Q 0, 1, 0. And I have a triangle in here between these 3 points. Actually, I want just a simple line, okay? The question is, find the angle in here, the angle theta in here. So what is theta? Okay, so to find theta, all I need to do is to find this vector, to find that vector in here, and then use the dot product formula. So PQ is what? For PQ, I need to subtract the components of Q minus the beginning point P. So PQ would be 0 minus 1, 1 minus 0, and then 0 minus 0. So PQ is -1, 1, 0. And then with the same idea, PR, the vector PR, would be 0 minus 1, so it would be -1, 0 minus 0, and then 1 minus 0. Okay, and then I'm gonna use the formula cosine of theta, which is equal to PQ dot product with PR over the length of PQ and then the length of PR. Okay, that's how we find the angle between two vectors. Okay, so I get -1, 1, 0, dot product with -1, 0, 1, and then over the length of this vector, which is -1 square plus 1 square plus 0 square, and then negative 1 squared plus 0 squared plus 1 squared. So I get negative 1 times 1, which would be 1, and then plus 1 times 0, 0 plus 0 times 1, 0. Divided by square root of 2, square root of 2, so I get 1/2. So cosine of theta is 1/2, meaning that theta is equal to pi over 3. So theta is equal to pi over 3. Great. Another example, this is example 4. Okay. Question is that are these two vectors negative, actually 2, negative 1, 0, and 0, 0, and 5, are they orthogonal? As we said previously, to detect orthogonality, we can use the dot product. If I find the dot product between these two vectors, and if it is 0, it means that the cosine of the angle between these two is 0, meaning that the angle is pi over 2. So I get 2 times 0 plus negative 1 times 0 plus 0 times 5. So I get 0, and the answer is yes, they are orthogonal to each other. Okay. Another example, example 5. Find the vector projection of the vector u, which is 6i plus 3j plus 2k, onto the vector v, which is I minus 2j minus 2k. Okay, so we're gonna use the formula for that. I have u over v. Okay, so the projection of u over v would be equal to what? Would be equal to v dot u over the length of v squared times v. Okay, so I need to calculate this product. So v, which is 1, negative 2, negative 2, dot product with 6, 3, and 2, and then over the length of them, which would be 6 squared plus 3 squared plus 2 squared, and then, okay, the length is squared actually. Oh, I put the length of u in here, so I need to replace it with the length of v, this one, which would be 1 squared plus negative 2 squared plus negative 2 squared, and then this is a square, and then the vector, let me erase the dot so that I don't confuse myself. So it would be 1, negative 2, and then negative 2. So it would be 6 minus 4, and then this one would be 1 plus 4 plus 4. So it would be square root of 9 squared, and then the vector 1, negative 2, and then negative 2. So I get negative 4 over 9 times the vector 1, negative 2, and then negative 2. Okay. Very good. And the last example would be example 6. A force is given by the vector f, which is 2i plus 4j minus 5k to move a box from a point A, which is 1, 2, 3, to the point B, which is 5, 0, and -2. Find the work done. Find the work done by F. Okay, all I need to do is to find the displacement and find the dot product of the force and displacement. So I need to find F dot D. F is 2 for -5, and then the displacement would be the components of B minus the components of A. So it would be 5 minus 1, 0 minus 2, and -2 minus 3. So I get 2 for -5, dot for -2, and then -5. So I get 8 minus 8 plus 25, so the work done is 25. So this is the work done by F. Okay, and